pencils down, pick up your colored pens. So today's warm-up was a little bit different. I asked you not to solve any of the first three. I asked you to decide which method do you think would work best and explain why. There has to be a reason why. Be prepared to tell me which method you thought and why. If you're going to tell me why because I took a guess, don't bother with that explanation. And if you're going to tell me, well, it looks like one I did before, that's not good enough either because you need to tell me why was the one before the way it was. So, equity bars are in effect, and here we go. Number one, which method would work best? I got student number 21, 18, and 12. Student number 21. I'm sorry? Okay, for some reason it's difficult to hear you, so I'll come back to you at the end. Student number 18, which method? We're on number one. Graphing. Okay, why? Okay, easy to change the slope intercept. Okay, student number 12, what'd you put? Why? Good, that's a good explanation. So, I would say that substitution or elimination would be best. At this point, graphing is not really going to be helpful to us at all. Graphing is something you have to know how to do. It is the basis for everything else. It's the foundation for all the other ideas. But substitution and elimination are shortcuts to graphing. And the problem with graphing is that it's very ineffective because we often can't find the right point because there's human error involved. When you do things mathematically and algebraically, the human error goes away as long as you don't make a mistake in the process. So I would accept substitution or elimination, and Laurel, for you, I would accept graphing as well because you gave a good explanation. Student, number 2, I've got student number 2, 17, and 14. We'll scrap student number 2, 17, 14, and 16. Student number 17, what'd you pick?
I chose graphing for number 2.
Why?
Because I kind of did the process of elimination. I saw number 1 was best for substitution. And for me, and then I chose, I was going number 3, but yeah, I saw that one.
Okay, but it wasn't that each question could only have one of those. It wasn't a matching system. This wasn't a matching game. Each one of them could have had the same answer. I didn't say that there's only one that's graphing and one that's substitution and one that's elimination. So you misunderstood. So it wasn't a process of elimination. I understand your explanation, but that's not what we were talking about. Okay? But you chose graphing. Student number 14, what'd you pick? Okay, why? Speak loudly, nice and loud and clear so everyone can hear. Okay, but you said two different things, because first you said something else. Okay, so you put elimination for that one. Okay, student number 16, what'd you put? Okay, well, I appreciate you saying graphing, but again, the same thing I'm going to say again. Graphing at this point is something we're not going to do. You're going to graph when I tell you to graph, but other than that, you're trying to avoid graphing. That was the whole purpose of the last 2 lessons. So I understand that some of you are not catching on. But you need to catch on because we're not going to continue saying the same thing over and over again as if you're not even here. Listen carefully to what I'm saying. Graphing is important, but it is not effective. It is not efficient. So it's a waste of time. Not only that, this equation is not in a very nice form for graphing. So why would you go ahead and do that? Draw a graph of 2 lines, mess up one of them, get the wrong answer, and then have to go and do the whole thing over again when you could do substitution or elimination and get the right answer on the first shot. And this is set up perfect for substitution right here. We have one of the letters isolated. So you're supposed to be thinking about these types of things at this point. You're supposed to be able to recognize what to look for which method. So Kaylee is going to leave here today and she's going to say to herself, well, if both equations are in standard form like in number 3, that tells me one method's going to work great. In number 2, I have one of the letters isolated. That means another method is perfect. And these types of things should be popping in your head, not a struggle. Okay? So let's go to number 3. What method did you choose for that? So we've got student number 22, 6, and 3. Student number 22. Okay, that's a very good explanation. Student number 6, what did you choose? Try to keep up with me, ladies and gentlemen, that you need to know your number. Student number 6, what did you choose?
I chose elimination.
Elimination, why?
Because it already had the 2 line, so all I had to do was put -1.
Very good. That's a great explanation. Student number 3, what did you put?
Elimination.
How come?
It was like all lined up and
Very good. So it's all lined up perfectly for elimination. And as both of the other 2 students said, you can see right here that this is not opposites, but it's very close. And all you have to do is flip the sign of one of them, and you'll get opposites. So this is set up perfectly for elimination. This is set up perfectly for substitution, and this is set up for substitution or elimination. It kind of depends on what you prefer. This has to be reordered so it matches this, or like Amari said, you can isolate one of the letters, like you could isolate the Y and use substitution. So either way. Now, in number 4, I asked you to choose one of the systems and solve it using the method you chose. So now I'm going to reveal the solutions to all 3. You only did 1. So mark your answer correct or incorrect. So number 1 was 3, 7. Number 2 is 2, 3. And number 3 is 3, -1. Mark your answer correct or incorrect. So, now you had to solve. Does anyone have any questions on how to solve any of these? Any questions? So let's talk about number 2. Give me a thumbs up if you used substitution for number 2. Okay? Give me a thumbs up if you did number 2. Okay, so what did you do to solve it? You used elimination. So what did you do? You rewrote the equation, this first equation? And so what did it come out as? Negative x plus y equals 1. Equals -1? No. I'm not sure what you did. You have to rearrange this so that everything lines up. So I'm not sure what you did. Did you get the right answer? Okay. So this could either be x minus y equals -1, or it could be -x plus y equals +1. It has to be one of those. Okay. Okay. But, so everyone's shying away from substitution, and I understand why, because it's challenging. But it's also very effective. When you have this set up, that means x is equal to that expression, and all you have to do is take that expression and plug it in right there. And look at what all you had to do. Y minus 1 plus 2y equals 8. This expression went right there. Now solve that equation. Look how easy this is. Y and 2y is 3y minus 1 equals 8. It's now a two-step equation to solve. So substitution, while I understand it's challenging, has its place. This was set up perfectly for substitution. Any comments, questions about that? Okay, so the good news for today is that you're not going to learn anything new, really. We're going to take what we've learned and we're going to learn how to really apply it to the real world. You've already been asked to do it. You've done it in your homework assignments. A lot of you struggled with it, but that's okay. As long as you made an effort, I don't care. So today we're going to really learn very well how to deal with these real-world scenarios. Because think of the whole point. What was the whole point of learning algebra? The whole point was to be able to apply it to do something, to make your life simpler, to bring you closer to a career aspiration, to bring you to higher level mathematics, and to solve problems. That's the whole point. So we haven't spent a lot of time doing that, but we're going to spend a lot of time doing it today. Before we get to the real world, let's kind of sum up what we know. So here are all the methods that you've learned. Graphing, substitution, and elimination. And so you're supposed to be able to pick which one would make most sense in which situation. So let's talk about graphing. I've said it during the warm-up, and I'm going to say it again. We're pretty much not going to use graphing for a real-world scenario unless we have to, unless we need the graph for something. But that's not going to happen very often. Because there's too many areas in graphing where we can make a mistake that leads us to a solution that's not correct. And it's a lot of work. Which leaves us with the other two. So when is substitution a good idea? Well, look at the examples all the way on the right. It's just like during the warm-up. We have a system in which one of the equations is isolated or both of them are isolated. That makes it really easy. Those situations are set up beautifully for substitution. What about elimination? Elimination is great when, like Yasmin said that everything was lined up perfectly in standard form, lined up in columns. And if we can easily get opposites, and so you can see we can easily get opposites there, and we can easily get opposites there. And so elimination works well in those situations. Also, coming into play is your comfort level. I would say that I find more of my students comfortable with elimination versus substitution. So Michael, during the warm-up, took a system that was set up for substitution, but he wasn't comfortable with that, so he did elimination. Guess what? Good for Michael. Doesn't matter. Because no matter what, you should get the same answer. Does anyone have any questions about this? So if you're missing some of this, that's fine. I'll leave a couple of lines of space. I have it printed out. You can borrow it and fill in the rest. Remember, this is note-taking, so you shouldn't be copying every word, and you should be using lots of abbreviations. But I want to spend a good amount of time today going over how to apply this to a real scenario. So now we're going to go ahead and look at a real example. You do not have to copy the text of this question, but you do need the table of information that we're going to use. But of course you need to read the question. So read it to yourself and then copy down the information we need. And then we are going to work as a whole group. We are going to take the approach today of I do, we do, you do. We are going to take that approach. I'll do something, we're going to do something together, and then you're going to try it out on your own. That's the approach we're going to take. Okay, so you've read the scenario. There's two different ways to go when you want to host. When you want to have a website. You can use an internet service provider like Comcast or Verizon or AT&T, or you can use a website hosting company like One and One or GoDaddy or something like that. And they do basically the same job, although a website hosting company would probably do a better job with your website itself. But each company gets to choose how they want to charge its customers. And so here I have an example of a generic internet service provider, which is called an ISP. And they have a setup fee of $10, and then each month you have to pay $21.95. The website hosting company has no setup fee, but then you have to pay $22.45 each month. And we are asked to find the number of months. Find the number of months when the cost will be the same for both companies. So, I want you to watch something. I do not want you to write at all. I want you to just look. Okay, so put your pencil down. But when I tell you to put your pencil down, that means your brain goes into high gear, your eyes are focused up here. If I wanted to, I could do this. I can make a giant table. This is the ISP. This is the website hosting company. This is 1 month. How much will the ISP cost for 1 month? Someone do that mental math for us really quick. Adrian? It'll cost us $31.95. How much will the website hosting company cost us for 1 month? Gary? $22.45. Nobody's writing anything. Okay? Are they equal? No. So I haven't found the number of months yet, right? So let's go to 2 months. How much will the ISP cost for 2 months? I don't know if you can do mental math with that. You might need to use your calculator. Anyone feel? I don't even know what it is. Let's see. It would be 22. So that would be 53. I don't know. What would it be? David, you got it ready? 53.90. Or is it 54.90? 53.90? $20. $2 more. What is it? 53.90. Okay. Thank you, David. 53.90. How much will the website hosting company cost? Yadesh? $44.90. Okay, are they both the same? No. So now I have to go to 3. Is this a very efficient, effective approach? I'm going to have to keep going and going and going and going and going until I find which column the numbers end up the same. Right? Not a very efficient approach. This is going to take me some time and a lot of calculators. And oh man, what if I punch one number wrong? Well, then I've totally messed up. So, not a very effective approach. So that's where equations become very important. Because equations tell us the pattern without having to write out the whole pattern. So now we have to learn how to set up an equation. Anyone think they already know the equation for the ISP? Anyone think they already know? Give me a thumbs up if you think you already know it. Got a few people who think they do? Okay. Tristan, what do you think it is?
10 plus 21
Okay. It's pretty good. Let's see if that works out. So let's back up for a second, see if he's right. What's the first thing I ask you to try and find when working in a real-world scenario? There's something specific you're supposed to find. Cheyenne? Yeah, totals. So let's find totals first. What are the totals, or total, in this question? Amir? That's the total after 1 month. What if it's at 4 months? What if it's 10 months? What if I let them work for me for 36 months? Okay, Gary? It's unknown, that's right. That's what I was trying to lead Amir to see. So we don't know what the total is. We don't know what the total is for the ISP, and we don't know what the total is for the website hosting company. It's a mystery. So what's something else I ask you to find when working in a real-world scenario? Alex? The rate. The rate. Very good. So maybe there's a rate in here. Is there a rate for anything? Catalina?
For the internet service provider, the rate is 21.95, and then for the website hosting company is 22.45.
That's right. Those are the rates because that's the cost per month. That right there is a clue. Per month. That's a rate. What else do I ask you to find? Ooh, starting to come back to you. Keshape? Yeah. A flat number or a flat fee, which could also be called a starting point. So what's a flat number or flat fee for ISP? Michael? $10. What is it for the website hosting company? Laura? Nothing. What's the last thing that we're supposed to look for when we're trying to do this? Chanel? Yeah, the missing piece. What is missing? In other words, what are we looking for? And that goes back to the actual question. What is it that we're looking for? Paige? The number of months. That's right. The number of months. And so we're going to call that X. The number of months is missing, and yes, in the real world we use letters like M and C and stuff like that. But to keep it consistent with what we've been doing, we're going to use X and Y. So we're going to call the months X. So now that leads us back to the total. What do you think total is going to be? It's going to be the Y. So we don't use question marks here in Algebra 1 Honors. That's a Y, and that's a Y. So now look at what has happened. We have an equation. It's just written straight down. So now let's write them across. And so if we write them going across, you see Y, which is the total, equals exactly what Tristan said before we even started. 21.95 times x, which is the missing piece, plus the $10, that gets you the cost for the ISP. And then we've got y equals 22.45x plus nothing, but we don't need to write that. And so now we have a system that we can solve. So now I don't have that giant table that I was trying to use. And here's the thing, some of you are thinking to yourself, well, Mr. Gallup, we were halfway done with the table. We could have just gone for another couple of minutes and found it. Now we've been on this for 10 minutes. Well, you're not really supposed to do this a month from now. A month from now, you're supposed to be able to do this mentally. A month from now, maybe even a week from now, you're supposed to be able to just look at it and go, oh yeah, I know this. Yeah, it's 10 plus 21.95x. You're just going to start seeing it because your experience will allow you the skill to do that. So we went slowly because we're learning right now, but you're supposed to be able to do this more quickly. Okay? So, any comments, questions on how we formed the two equations? Paige?
When we set a question like this and define how many months total cost for both of them would be, wouldn't we just do 10 plus 21.95x equals 22.45?
So yeah, there is another way to do it, absolutely. So go ahead, you do it your way, but you're going to see how it works out in a second. So, which method will work very well for this? Look at what you just wrote. Which method will work really well? Amari? Yeah, this is set up perfectly for substitution because look at this right here. Y equals that. And so this can be put in place of that y right there. And we get an equation with one variable, which was the whole point. So if I take this and put it right there, I get 22.45x equals 21.95x plus 10. Solve the equation. So let's all work simultaneously. You can do this. You already know how to do it. You should already be feverishly trying to do it. You already know the skills. No hesitation whatsoever. Subtract 2195x from both sides. And so Paige, when you did it, what did you get on the left?
I got
0.5x equals 10. Very good. Divide both sides by 0.5. That disappears, and you get x equals what? Got a bunch of people who got it already. 1, 2, 3, 4, 5, 6, 7. Yasmin, what'd you get? What'd you get, Keshape? Yeah, you get 20. And since we were just asked for the number of months, and we were not asked for the total cost at that point, we actually can stop because that's all we were asked for. Find the number of months, and x is the number of months. And so we get 20. If we wanted to find out the cost, we could take the 20, plug it in right there, and that will tell us the total cost after 20 months. But we weren't asked that question. We were only asked for the 20. So the answer is 20 months. Any comments or questions on how we went about this? So we organized our information, we formed a system, solved the system, and answered the question. Have to make sure you answer the actual question. Any concerns or problems, issues? All right, so now comes the you do part. Checkpoint number 1. You do not have to copy the question. I need the answer. I'll put 4 minutes on the clock. You can take the paper out and put it right here so you guys can look together. So you've got about 2 minutes left, so I have some students who are done already. My students who have more than one person in a team done, go ahead and compare your answers. You can take the paper out, you can compare with Paige over here, or Isabella, or Kathleen, or Jesse over here. However you want to do it. Alex, I leave it up to you. He's saying you did something wrong. So. All right, give me a thumbs up if you got an answer. Good, put your thumbs down. Anyone want to be brave? Oh, lots of brave people. Oh, we're doing so well. Oh, this is very refreshing. All right, we'll start with Kaylee, and then we'll go to Amani, and then Catalina, and then Chanel. Go ahead. Okay. 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 So all 4 of you think that it is 4 months, and it is. And I just wrote it out in a more elaborate way just so you could see a deeper explanation. If you finished finding the ordered pair, it actually comes out to 4, 130. So the cost at that point will be $130. And so in 4 months, very good job. And I walked around, I saw a lot of people doing a good job. Anyone have any comments or questions on how we applied what we've learned? Okay, so now we're going to do another example, and what you're going to see is that there's more than one type of system scenario that we can explore. So it will require a little bit of a shift in thinking. So I'm going to put up example 2, and again, you don't need to copy the question, you need to read the question carefully. And there's a typo here. So I'm going to try something a little bit different with you guys. We'll see how it goes. I haven't done this with anybody else. But we're going to look at 3 questions all kind of simultaneously. This is an even more classic style system question. So could someone remind us, what is the first thing I always ask you to look for in any real scenario? Tristan? Total. So could someone tell us what the total is in this question? What is the total, Laurel? Okay. I think you said 775? This? Oops, excuse me. So there's a total right there. Okay? Anyone agree, disagree, have a comment, anything at all? Gary? There's another total, it's 12. Okay. Give me a thumbs up if you agree that there's 2 totals. Okay, some of you see it. Good. Put your thumbs down. So here is why this is, I consider, a classic style system question. You have 2 totals, and one is in 1 unit, in this case, money, and the other is in a different unit, in this case, objects. They're related to each other because the objects cost money. But finding the totals first helps you figure out the system. So watch this. It's just like we learned at the beginning of the year. You take the total and you put it right after the equal sign, but now we have 2 of them. Take the total, put it right after the equal sign. Now here's where I'm going to do something that I haven't done with any other class. We're going to come back to this question, and I want you to leave some space, leave a few lines of space, because you're definitely going to be doing some work. And let's look at 2b, and I want you to read 2b. So what do you notice about this question? Amir?
They look the same.
They look the same. What? Give me something specific.
Because they both have 2 totals and
Okay, well, hold on. There's 2 totals here?
yeah,
What are they?
44 and 7.
Okay, so 44 and 7. He claims that those are the two totals. Give me a thumbs up if you agree with him. Okay, some of you agree and some of you don't. Okay, you don't agree? Oh, you do agree. Okay, but he is right. There's two totals, and I love how he said it. It's like the same question. And so I want you to notice again that we have money and then we have objects. They're related because the objects cost money. But this guides us on what to write down. So now we can write down equals 44 and equals 7. Now, what about the rest of this question? What information are we given? Cheyenne? Okay, so we're given two what? Say that again. Given two rates. Look at this. We're given $5 per and $8 per. And now watch, I'm going to go back to question A. What do you see? Go ahead, Cheyenne. 50 cents per, 75 cents per. Now read the last statement. And now read, now the actual question, the last sentence. Now read the last sentence of this one. There's a phrase in there that showed up in both. What phrase shows up? There's actually a couple of phrases that show up in both. Adriana?
How many?
Okay. How many shows up in both? How many shows up in both? How many? What else shows up in both? Michael?
Each.
Of each. Notice that it says of each. So, how many things are missing? How many things are missing? Way back in September, we did equations that had one thing missing. How many things are missing in this question? Paige? How many things are missing in this question? 2. So what if we said in this question that felt was X and cardstock was Y? And then if we go to this question, we say that athletic socks is X and dress socks is Y. We just figured out one of our equations in both situations. We're going to buy 12 sheets. Some of them are going to be felt. Some of them are going to be cardstock. Can someone fill in one of our equations here? One of them can get filled in right now. Catalina? That's right. X plus Y equals 12. Because the number of sheets of felt plus the number of sheets of cardstock must equal 12. Because the person is buying 12 objects. Now look at part B. Can we fill in one of the equations? Should be starting to click for you a little bit more. Go ahead, Cheyenne, you're on a roll. X plus Y equals 7. Because Harlan is going to buy 7 objects. Some of them are going to be the athletic socks. Some of them are going to be the dress socks. Together, they must be 7. So now we just need the other equation. And here's where understanding that this is money, and you don't write that in an equation. I'm just putting it there quickly. Understanding that that's money will help you figure out the rest of that equation. Anyone know that whole equation? Got a few people who know it? Go ahead, Laurel. Okay, you've got the right idea, but does felt cost $7.75 each? We take the number of sheets of felt and you multiply it by something. That was very good. But does it cost $7.75 each? How much does it cost each? So now tell me again, what is it going to be? plus what?
75.
Yeah, 0.75y. Because when you have the money, now the money gets put in. Money times how many? Money times how many gives me total money. Now look at part B. What's the rest of the equation going to be? Now it should be clicking for you. What's the rest of the equation going to be? Yadesh? Yeah, 5x plus 8y equals 44 because money times the number that we're buying plus money times the number that we're buying must equal the total amount of money. And so we can see that this is a classic style question because we have money and objects and we get two equations. I'm going to wrap up in a moment, but what method would work really well for this? Now we're ready to solve. So what method, Garion? Substitution. Keshape, what were you going to say? Elimination. So you guys disagree, but it doesn't matter because they're both going to get the same answer. We did this yesterday. I was able to get through this question with a different class. We did elimination, and it actually works out beautifully. Substitution will also work out beautifully as well. I am running out of time, so we're not going to actually solve it. For your homework, you are going to solve whatever I ask you to solve. But the more important thing to learn today was how to translate from the words into the system. And that was my goal. So I'm pleased that we were able to do what we did, and you guys did a really good job. So draw a line across your paper. Your homework tonight is in the old workbook, the thin red workbook. And you are going to do on page 75, numbers 19 and 20, and on page 76, numbers 22 and 23. That's 4 questions. That's it. But they take some work. They take a little time. And you are going to have a quiz tomorrow on 5-1 to 5-3.